Okay, we are solving the problem 2698. Find the punishment number of an integer. So given a positive integer n, return the punishment number. And the punishment number of n is defined as the sum of the squares of all integers I, such that I is between 1 and n. And I square and the decimal representation of I square can be partitioned into contiguous substrings such that the sum of the integer values of these substrings is equal to I. So basically, let's consider the first example. Given n10, you have to find all integers from 1 to 10 such that uh, so such that the squares can the digits in their squares can be uh, arranged and added to form the number itself. So in the first example you have 1. Since 1 times 1 is equal to 1, that's fine. 9, since if I equal to 9, so 9 square 81, and 81 can be partitioned into 8 and 1, so to get this sum 9. Similarly with 100. And one more example would be the second example. Here you have 36. So 36 square is 1296, and we can get 36 from 1296 using 1 plus 29 plus 6. So uh, so the constraints on n are not that big, so uh, kind of a brute force recursive solution works for this problem. So let's write a result. What we have to do is go from 1 to n, 1 to n plus 1, and let's add to it whatever we get from a solve function where you pass the I value and just return the result. Now for writing the solve function, let's start with def solve and x, and we can define a target variable to be x times x, and then the number to be string of target. We can store this in store the digits as characters in an array or chnum, and we can have n as the length of that array. So we can use a normal recursive approach here. So let's write def recur, and we want, so this approach is similar to the DP approach where you can zero and knapsack, where you take one character and then where you have the option to take one character or keep it the same and take it the next turn, so take and leave approach. So similarly, to implement that, we can have two pointers, a current, a previous, and the total sum. For the base case, if current is equal to n and total is equal to x, uh, and finally we want the current and previous pointer to be at the the same, and if current and previous are same, then we can return true. Otherwise, if let's say current is greater than equal to n, we can just return false. So these are our base cases, and for the first, let's take current case. So by take current, I mean for the second example, for 1296, you're starting with current and previous at 0, so you want to take 1 as a separate integer. So for our code, we can write a temporary variable, and we can iterate from I in range previous to current plus 1. So whatever previous whatever previous variable is pointing to, we have to take that till the current. So for example, if the previous is pointing to 1 and then here current it has 2, we have to take it the entire um, 12 as our integer. So we can just write temp plus equal to of I, and then let's have a result variable. By default we'll set it false. So for the first recursion we can have result or equal to recur, and as we are taking the current variable, the current is gonna be incremented by 1. The previous is also gonna be the same as current, and here we are gonna have total plus integer of temp. We add the uh, the temp to the total. And for the case where we can leave the current variable, let's uh, write it as leave cur, and here we can basically uh, recur from previous to the next, and sorry, this is gonna be current plus 1, and this is gonna be previous, and the total is gonna remain same. We are not adding anything to the result, and after that you can just return the result. And finally we can return 0 if recur of 0 0 and 0. uh, if this is false we can return 0, else we can return. And this should be good enough. Let's give it a run. So it is giving me some error. Let me verify the code again. Oh yeah, so I found the bug. It is, we have to return 0 if not, or else we have to return target. That target is going to be added to the result, right? That's why. And let's give it a submit. Yes, there you go. This solution is definitely on the slower side. It's of n square, and oh yeah, oh no, it's not, of 2 raised to n. The editorial mentions a solution of having like O of n times n raised to 2 raised to log n something. So I think it's still a bit faster, but yeah, this should be a doable solution if you have decent understanding of uh, recursion and backtrack. Uh, yeah, there you go. All right, see you tomorrow.